All right, determine the equation of a real quadratic given that p of 4 minus 3i equals 0. Now, you'll remember from methods that with the factor theorem, if when you substitute a point into your quadratic and you get a value of 0, it means that that is a factor or a solution for that quadratic. Something else you need to know is that because you may have forced a difference of perfect squares, if one of the roots is a complex number, the conjugate of that complex number must also be a root. And that's actually called the complex conjugate root theorem. All right, so we've been given that p of 4 minus 3i is equal to 0. So that, therefore, okay, because of my factor theorem, 4 minus 3i is a root of my polynomial in Z. Okay, and then I can say, therefore, 4 minus 3i conjugate, which is 4 plus 3i, is also a root of p of Z. All right, so therefore, my two roots are going to be Z equals 4 minus 3i and Z equals 4 plus 3i. All right, now those are my two solutions or my two roots. I need to work backwards to get that to the original equation p of Z. All right, so that would mean taking it back over to the left-hand side. So that's going to look like this. Z minus 4 minus 3i equals 0, or Z minus 4 plus 3i equals 0. Thinking back, you're working backwards from your null factor law. So therefore I can say, well, my original p of Z must have been that multiplied by that. So Z minus 4 minus 3i times Z minus 4 plus 3i. And now all I have to do is expand that. But there is a way that we can make that nice and easy, because if I expand, I'm going to have Z minus 4 plus 3i and Z minus 4 minus 3i. Okay, and I can see that that can be written as an a minus b, a plus b, because look here, Z minus 4, Z minus 4, plus b, minus b. So actually what I've got is a difference of perfect squares that I've got Z minus 4 all squared minus 3i all squared. And yes, you could have expanded it all separately, but it's quite nice to have seen that. And that then gives me Z squared minus 8z plus 16 minus 9i squared, but I squared is equal to -1, so it becomes Z squared minus 8z plus 16 plus 9. So therefore my original polynomial was Z squared minus 8z plus 25.